All right, moving on to the number 5, we're going to be working with samples. So we're going to be looking at like how to kind of intro to gathering samples and different things with uh, kind of what you have to look out for when you do gather samples for your data and you do statistical analysis on them. Okay, because not all samples are great, and we've got to watch out for those. So the first thing, what a sample is. So what a sample is it's a part of the population. Okay, we can't do a census, which is counting of everybody in a population. We can't do that all the time because of time, money, or it's just not possible. Okay, and so we use a sample, which is a smaller subset of the population, to be able to predict what the whole population would say within given some leeway into our answer. Okay, and so that's what a sample is. It's a small proportion of it's a part of the population. And so the sample proportion is the ratio that occurs the size of the sample over the total. Okay. Given inside this sample. So if you were to look at, if you wanted to find, what's the most popular sport in America, instead of going through and asking every single person what their favorite sport is, you would only, you try to find a good range of about, a couple thousand people and go, what's your favorite sport? And so from there, if you got, let's say there was 2,000 people, and you found out that 800 liked baseball. Okay, so let's say 800 liked baseball. The sample proportion would be this fraction right here, in which you would reduce down to about, what is that, 2 over 5? So we would say about 2/5 of the population like baseball. And that is our sample proportion because we took it from our sample. Okay. So about 40%. Okay. So it's the number that the event, whatever it is we're looking at, occurs over the total sample size. All right, so if we're looking at this out of 110 students that are at the school, let's say this is, there's 110 students that are able to vote or at a school. 78 of the students voted that they wanted to go on a trip down to New Orleans, down in Louisiana, somewhere around here. And then 26, not 28, 26 chose they wanted to go to Detroit, in Michigan. And so that's where they wanted to go. And we have some that chose not to vote or did not care. We want to know what's the sample proportion for each city. And so all we have to do is we just go, well, for New Orleans, it would be 78 over 110, and for Detroit, it would be 26 over 110. And then we would find that decimal, find that fraction, find that percentage, however we want to put it into to find our answer. Okay, but that's all it is for the sample proportions. You just take however large the sample was, that's your denominator, and then your numerator was how many wanted that certain one. Okay, so as you see here, looks like New Orleans about 71%, and Detroit was about 24%. Okay. All right, so sample taking methods. So there's a couple ways of taking samples. Actually, there's many ways of taking different ones. The two that are written up here, random sample and stratified sampling, are two methods that are used commonly. A random sample is basically, I have the people in this town of Houston, Texas. I want to know how many people want to have a hockey team down in Houston. So if I want to do a random sample, what I would do is that I would pick randomly out of everybody in Houston. I would just pick however many people I wanted, 600, 700, and I would just pick them randomly, Doesn't matter. I'm not looking at anything specific. It's kind of like putting everybody into a lottery and then picking them out one by one. You don't look at them. You don't care, anything about them. You're just picking them at random. You're not looking for anything specific. Okay. Now, the problem with a random sample is that if, let's say, you want to take a random sample of Houston, but you only took it in, the southwest region, well, maybe that's, maybe they don't even know what hockey is. A lot of them, don't care about hockey. They're football fans or they're baseball fans, and we don't want a hockey team down here, type of thing. And, or, they're just not interested. And so what could happen is that you could get a slanted to one side or the other with your answer. So that's a problem with a random sample, is that you could have major bias, bias in your sample that you've taken. Now, it can occur. It doesn't mean it will always occur, but it can occur. Stratified sampling, which is this one, tries to negate this. And what it does is it breaks up the population into different groups. It could break it up into male and female. It could break it up into age, teenagers, young adult, 20-somethings, middle-aged, and then seniors. And so it breaks it up into that, and it could break it up into, social economical. It could break it up, education. It could break it up in many different ways. And these are called strata. And what it does with a stratified sampling is you go, okay, I want to have an equal proportion for each one of these. So so for male and female, you can go, okay, I want a 50-50 split. I want 50% male, 50% female. Okay. I want, 25% teenage, 25% young adult, 25% middle-aged, 25% senior. Okay. Or you could change those percentages and go, okay, well, this is more important to probably the middle-aged and young adult and not so much with the seniors. And so we would focus on those more. Those would have a higher percentage and the seniors would be less. And so that's what stratified sampling does. It tries to get a sample that is equal, or it's similar to the overall population. Okay, just scaled down. That's what stratified does. And it's just kind of another way of doing it, and it kind of tries to get rid of the bias. Doesn't mean it won't be there, but it just tries to get rid of it. The last one that I'd like to mention is called convenience sampling, which is if you ever see people out front of your grocery stores going, hey, would you like to take a survey? And you go, oh, okay. Yeah, those are convenient samplings. Basically, you try to do something really quick, easy, and go, hey, you, hey, you, hey, you. This is also phone calls. If you ever answer the phone and hi, welcome to blah, 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 blah. We would like you to take a survey. You go, no, click. That's a convenient sampling. Some people do go through those surveys. And so convenient sampling is just something that's easy, quick, or easy and cheap so that they can get the data. The last one, if you ever go to a fast food restaurant and they go, hey, if you take this survey, that's also convenient sampling because you choose if you want to take it. They don't put too much effort besides just telling you. Okay. So that's just different data taking techniques. All right. Sample size and margin of error are kind of important whenever you take a sample. There's something called the law of large numbers, which basically says that the larger your sample size, the closer it will be to the actual number, or the smaller the variations will be. If you take a small sample of like 10 people and you ask, who should win this election between candidate A and candidate B? And if you just take like 10 people, you could have a lot of people picking candidate A. But in the overall population, maybe most people want candidate B. And so what happens is that you get this small variation of, or you get this large variation if you have a small sample. If you get larger and larger and you get more and more people, more data points, the smaller and narrower the answer becomes. And it's better for you. Okay, so you always want to get a larger sample size because that margin of error will decrease. Now, the margin of error kind of tells us, okay, there's an error in this and we know it. And if you ever see a poll, like for any type of election, it says, oh, this person's up by 5 points with a 3% margin of error. What that is it's saying, okay, this is not perfect. We know that. but there's going to be an error, but we think the error is only going to be about 3% left, or 3% on either side of our numbers, or 6% or 1%. It's just saying, okay, this isn't perfect. It could be either way, whatever. And so to find the margin of error with a random sample, what you're going to do is your margin of error will be approximately plus or minus. You always want to do plus or minus because you can always have the number be larger or smaller for the percentage-wise. 1 over the square root of the total number of data points that you do. So the larger the sample, the smaller the margin of error is. So if you think about it, let's say I took a sample of 3 people. So my n would be 3, which is right there. 1 over the square, actually no, let's go 9. Let's do a nice round number. So I took a sample of 9 people. So it'd be 1 over the square root of 9, which is 1 over 3. Which means, and then you multiply that by 100, which means that my margin of error is plus or minus 33.3%, which is a huge margin of error. Basically, you're saying, yeah, these numbers probably aren't even close. There's a 33% chance, or the points could swing 33% either way, type of thing. So, again, the larger the number, the smaller it gets, okay? Your margin of error. So let's say we do this. We take a straw poll. And 84% of the people asked said that they liked Tantrum, okay? Tantrum, the energy drink, Tantrum. And so they like that over all other drinks. They just need that Tantrum. And if there was 5,000 people that took part in this poll, we want to know what's the margin of error of it. Okay, and then we want to kind of estimate, okay, what is the actual number? So what you'll do is you'll plug it into your margin of error. So margin of error is equal to plus or minus 1 over the square root of 5,000. And you'll calculate it that you get about plus or minus 0.0141, which is about 1.41%. So that means there's about a 1.5% chance that it's not 84. And so if we put up our numbers, our actual number, the actual percentage by our estimation, should be between about 82.59% and 85.41%. And that is what we would think would be the actual number of people that enjoy Tantrum over all other energy drinks, or all other drinks. Okay, so as you see, Marshall and Ted like Tantrum a lot, like 85% of the people that took this survey. All right, so your IRAT for this one. Your IRAT is a setup where we have the town of Algelus. There's an election for mayor, and before the election there was a poll of about 1,500 people, and they wanted to predict the outcome. So for the candidate Pythagoras Newton, there was about 846 votes, and for the Riemann Euler, there was about 654 votes towards that person. So the first thing you're going to want to do is find the sample proportion for each candidate. Okay, so find the sample proportion for each of those, and then the next part is find the margin of error for this survey. Okay, so find the margin of error and find the sample proportion for the candidates.